Gaseous state. Gas law. Boyle's law. At constant temperature, the volume occupied by a given mass of a gas is inversely proportional to its pressure. V is inversely proportional to pressure Q's. PV equal to constant. P1 V1 equal to P2 V2. A, B, C. Charles' law. At constant pressure, the volume occupied by the given mass of a gas is directly proportional to its absolute temperature. V directly proportional to temperature. V upon T is equal to constant. V1 upon T1 equal to V2 upon T2, or V1 upon V2 equal to T1 upon T2. Also at constant pressure, the volume occupied by the given mass of a gas increase or decrease by 1 upon 273 of its volume at 0 degrees Celsius for every 1 degree Celsius rise or fall in temperature. Vt is equal to V0 plus V0 upon 273T. Gay-Lussac's or Norton law. P is directly proportional to temperature. P upon T is equal to constant. P1 upon T1 equal to P2 upon T2, or P1 upon P2 is equal to T1 upon T2. P1 is equal to P0 plus P0 upon 273T. Avogadro's law. Equal number of molecules of a different gases under identical condition of a temperature and pressure occupy the same volume. Combined gas equation. PV is equal to nRT, where P is the pressure of the gas atmosphere, V is the volume occupied by the gas liter, N is the number of mole of the gas present, N equal to W upon M, T is the temperature of the gas in Kelvin, and R is known as the universal gas constant, 0.0821 liter at atm per mole per Kelvin. Value of universal gas constant are in different units. Value 8.314 units, JK inverse mole inverse value 0.0821 unit, atmosphere liter per Kelvin per mole. It value 8.314 units, K Pascal dm cubes per Kelvin per mole, value 1.99 calories per Kelvin per mole. Aqueous tension. When a gas is collected over water, it also gets saturated with water vapor. The pressure exerted by water vapor is called aqueous tension. The pressure of the dry gas is calculated as follows. Density of the gas. Density is equal to Pm upon RT, where m is the molar mass of the gas. Partial pressure. The partial pressure of a gas in a mixture is defined as pressure which the gas would exert if it is allowed to occupy the whole volume of the mixture at the same temperature. Dalton's law of partial pressure. The total pressure of a mixture of non-reacting gases is equal to the sum of the partial pressure of the constituent gases. Graham's law of diffusion. The rate at which a gas diffuses is inversely proportional to the square root of density of the gas. Rate of diffusion of a gas is equal to volume of diffusion upon time taken. R1 upon R1 equal to square root D2 upon D1. Since vapor density is equal to m upon 2 molar mass, R1 upon R1 is equal to square root m2 upon m1. The kinetic theory of gases. The gas consists of a large number of very small spherical tiny particles. The molecule of a given gas are completely identical in size, shapes, and mass. The volume occupied by the gas molecule is negligible in comparison to the total volume of the gas. The molecules are in rapid motion, which is completely random. During their motion, they collide with one another and with the side of the vessel. The pressure of the gas is due to collision of molecule with the side of the vessel. All collisions are perfectly elastic. There is no force of attraction or repulsion amongst the molecule. PV is equal to 1 upon 3 mnu square RMS, where P is the pressure exerted by the gas, V is the volume of the gas, M is the average mass of each molecule, N is the number of molecule, and U is the root mean square RMS velocity of the gas. Kinetic energy per mole of the gas K is equal to 3 upon 2 RT. It does not depend upon nature of the gas. Kinetic energy per molecule of the gas Ke is equal to 3 upon 2 kT, where K is known as Boltzmann constant. Molecule speed of gas molecule. Root mean square speed. URMS, it is defined as speed possessed by the gas molecule. If the total energy of a gas is equally distributed amongst all its molecules, it is equal to the root of mean of square of the speed possessed by the gas molecule. URMS is equal to square root u1 plus square plus u2 square plus u3 square plus u4 square plus un square upon n. URMS is equal to square root 3 RT upon m is equal to square root 3 P upon rho. RMS speed of a gas is dependent upon its absolute temperature as well as molecular mass, nature of the gas. Most probable speed. It is defined as speed possessed by the maximum fraction of molecule of a gas. URMP is equal to square root 2 RT upon m. Average speed UAV. It is the average of molecular speed possessed by the gas molecule. UAV is equal to square root 8 upon RT upon pi m. RMS speed square root 3. Average speed square root 8 upon pi. Most probable speed square root 3. RMS speed 1. Average speed 0.0921. Most probable speed 0.816. RMS speed 1.732. Average speed is 1.595. Most probable speed is 1.414. RMS speed 1.224. Average speed 1.128. Most probable speed 1. Real gases and ideal gases. The gases that obey gas law, Boyle's law under all conditions of pressure and temperature are called ideal gases. No gas is an ideal gas. The gases that obey gas laws, Boyle's laws under all conditions of pressure and temperature are called real gases. All gases are real gases and show deviation from the ideal behavior. Causes of deviation from ideal gas behavior. Actually, gas molecules face intermolecular attraction, and so the pressure exerted by the gas molecule due to their collisions with the wall of the container is less than what is expressed. Gas molecules to have the size of their own, and so the volume actually occupied by the gas is less than what is calculated to be. Compressibility factor Z, Z equal to PV upon nRT. Boyle's temperature. The temperature at which real gas behave ideally is called Boyle's temperature. At Boyle's temperature, the value of Z remain nearly equal to unity over a good range of pressure. TB equal to A upon PR. Van der Waals equations. P plus AN square upon V square under bracket V minus NB equal to nRT. P plus A upon V square V minus B equal to RT for 1 mole of the gas, where A and B are known as Van der Waals constant. Van der Waals constant A, Van der Waals constant B, used in pressure correction, used in volume correction. Van der Waals constant A depend upon the intermolecular force between gas molecule. Van der Waals constant B depend upon the actual size of the gas molecule. Van der Waals constant A known as coefficient of attraction. Van der Waals constant B known as co-volume or excluded volume B equal to 4V. V is the volume of one molecule of the gas. Unit of Van der Waals constant A is atmosphere L square mole minus square. Unit of Van der Waals constant B per liter per mole SI unit of van der Waals constant is n m raised to 4 square m raised to 4 mole raised to minus 2. Van der Waals constant B SI unit is m cube per mole. Condition when the real gas behave as ideal gas are high temperature and very low pressure. Critical temperature Tc, the maximum temperature above which a gas cannot be liquefied by application of whatever high pressure. Tc equal to 8A upon 27 RB. Critical pressure Pc, the minimum pressure required to liquefy a gas at its critical temperature. Pc is equal to A upon 27 V square. Critical volume Vc, the volume occupied by 1 mole of a gas at its critical temperature and critical pressure. Vc is equal to 3B. Joule-Thomson effect. When a non-ideal gas suddenly expands from a high pressure to a low pressure, there is a temperature change. It is an adiabatic effect. For any given pressure, a real gas has an inversion temperature above which expansion at constant enthalpy causes the temperature to rise, and below which expansion at constant enthalpy causes cooling.